So the last two topics we need to complete it in social network analysis. That is finding the subnetwork. Finding the subnetworks. So large network could be better analyzed because when we say social media, social network analysis, it's not small. Okay. The large network could be better analyzed and managed if it can be seen an interconnected set of distinct subnetworks. So when I say subnetworks, so this is almost like the cluster analysis of the nodes. So all the nodes with the strong tie-ups or the connectivities between them will be belongs to one of the subnetwork, and it will be having even separate subnetworks also. So this is an unsupervised learning technique actually. So as we have studied and understood the a priori algorithm, so a priori there is no correct number of subnetworks in a network. So the usefulness of this kind of a subnetwork structure is being used for decision making. So which is the main criteria for adopting the particular structure. So the example how the network with the distinct subnetworks will be connected means, so there will be a node. Okay, so you will have a lot of other nodes. These are all the small what circles I am writing it. It is the other node and it is being connected to this like this. So this is one subnetwork. So similarly, even the same nodes can also be used to connect with another subnetwork also. Another subnetwork also, something like this. And even these can be also connected, something like this. Okay, so a mesh kind of a complete structure will be defined as a network with the distinct subnetworks. So visual representation of these kind of subnetworks can help us to identify the subnetworks, and we can use the use of the color can help us to differentiate and distinguish between the types of the subnetworks, because when I wrote it in the black color, so it may not be very much applicable, or we cannot differentiate and distinguish between the subnetworks. But when we use the color to represent the subnetworks, so then we can easily understand that how many subnetworks are there, something like this. Okay, so this can be connected with this can be connected with this, and again these nodes can be connected to this, something like this. So I'll just show you the sample diagram of the network of subnetworks here. Let me enlarge it. Okay, so here is the network of sub-networks, how it looks like. So this is the one. So, but since it is in the black only, so we're not able to make out, but we can see something like a dark black and a gray color one. See, this is the one, what I'm highlighting right now. So you can make an observation. See, this is, oh, on picture, I'm not able to do it. On picture it is not allowing me, but you can find out that the dark black color spots are the circles which are there connected to the nodes, and that is one subnetwork. So one is gray colored one. So this is where I'm making the mouse to be moved. So gray colored one. So like this, visually we can use the visual representations of the networks which can help us to identify the subnetworks. And when we use the color code or the colors, so which can help us to distinguish and differentiate between the types of the nodes, and we can represent the strong tie-up with the thicker or the border lines also. So there might be some lines light, some lines thick, or some lines with a colored. So the collection of stronger relationships around the hub node. See, these are all the hub nodes. What I wrote it even in the notes also. So this is my one hub node. Okay. So this is my another hub node. This is my another hub node. So similarly, you can find it out here. 1, 2, 3, 4, I think 5, 6, 7, 8, 9, I think n number. So 9 only I could count it, but there are more than 9 or 10 subnetworks available here. So in that particular case, what it happens means a hub node could be representing the distinct subnetworks. So when I see that this particular part of the dark black where I'm using the mouse to encircle it, no, so this is the mouse which is pointing is the hub node, and all these are the nodes which are being connected to that particular hub node. So then this is one subnetwork, and similarly here one gray color hub node is there, and all these where I am encircling, so these are the cluster of the nodes which are connected. So like this we can have n number of subnetworks. So a subnetwork could also be used to be a subset of nodes with a dense relationships among them, and one or more nodes can also act as the gateways to the rest of the network. Okay, so then how do we compute the importance of the node? So which node is important out of this node is important, or this node is important. So how do we really come to know the importance of the nodes, that is computing importance of the nodes? So when the connection between the nodes in the network having the directions to them, so then the nodes can be compared with the relative influence of the rank. So here the importance and the influence and the rank of the node will be used to interchangeably apply for the purpose of finding out the importance of the particular node in the network. So this node can be used as an influence flow model, that every outbound link from that node can be considered as the outflow of the influence. So how many outflows are there from that particular node? So that gives the information about the influence of that particular flow model of the node. So the computational task can be used here to identify, to find out the set of the rank values that satisfies this set of links between the nodes. So it is an interactive task wherein we can begin with some initial value and we can complete the computation to iteratively till the rank values stabilize. So, but in this kind of a subnetwork, what I have shown, it's very difficult. So let us take a sample information or a simple network as an example, then we can find it out this. So let us consider one example of a simple network with only 4 nodes. So let us have only 4 nodes. So let me call those nodes as A, B, C, D. Okay. So let me use the black color, because the other colors will use it to represent this thing. Okay, how do we distinguish and all? So let me draw. It's a very simple network. Okay, so A, B, C, D. So there are 4 nodes. So let us draw the outflow arrows also, means pointing lines which are connecting. So A to B is 1. So I am pointing it out A to B. Okay, and even B to A is also there. Okay, then D to A, I'm not writing it very properly. Okay, so let me, okay, this is one, this is one, this is one, and A to C also one. So let us write the arrow marks pointing from where to where. So B to C, there is a flow. A to C, there is a flow. C to D, there is a flow. Then D to A, D to A. So this is a simple network example comprising of 4 nodes A, B, C, D, and how many directed links between them are there. So let us count it. How many lines are being drawn? So 1, 2, 3, 4, 5, 6. So there are 6 directed links. 6 directed links between all these 4 nodes which have been shown in the figure. Okay. So now how many links are bidirectional here? So we need to check that also. How many links are bidirectional? Is there any bidirectional arrows which have been written? So node A links to B. Node A links to B, correct? So node B also links to A. Okay, so here let us note it down. So what are the links which are there? Okay, so A to B, there is a link from A to B, and we go sequentially. So A to B, we are in B. So B to C, C to D, then D to A, and from A to C. Okay, so A to C, then finally B to A, then finally B to A. Okay, so these are the links which we got it here. So now the main intention is to find out the relative importance. So we need to find out the relative importance of the node. Relative importance of the node, or we can also call this relative importance as rank. Okay, or we can say that every node in the network, so what is the importance of that node in the network? So we are trying to identify that. So this will help us to identify that most important node or nodes in the network. So this will help us to know or identify the most important node, or it may be more than one node as an important node in the network. So let us begin understanding and evaluating and computing this for the given example scenario. So let us begin assigning the variable values for the influence or the rank value of the each node. So let me call it as the rank of the each node will be called as, okay, for A node I call it as RA, okay, so RB, RC, RD, okay. So the intention is to find out the relative values of these variables. So we are allocating and assigning the 4 variables to 4 nodes to find out the relative importance or the rank or the variable of influence value for each node in the network of 4 nodes. So now there are 2 bound links. We can find it out from node A to node B, node A to node B, and node C. So we can make an observation. Now I'll use another colored to show you that. So let me use the red color. Okay. So here A to B is there. Okay. So what I am rewriting it in orange or red color. So A to A to node B and node C. There are 2 outbounds which we can find it out from A. Correct. So what does it mean? So that thus both B and C receives half of the node A's influence, because A is being shared. A got one outbound arrow mark going towards B and again one more arrow mark going towards C. So means that A's influence or A's what you could say that the relative value of A Okay, so will be shared equally between the two nodes B and C. So half of the node A's influence will be given to B, half of the influence of A will be given to C. So similarly, there are two outbounds. There are two outbounds from B also. That is B to A. Okay, so then B to C. So similarly, when I say there are two outbound links from B node to C node as well as A node. So similarly, B's influence also will be shared. That is, half of the influence value will be shared with A and half will be shared with C. So again, we need to check for any other node. Okay, is there any two outbound links? So from C, is there any two outbound links? No. So let me use the green color to represent that. So there is only one. Okay, so there is only one from C to D. There is only one outbound from D to A. So C and okay, so C and D. So that is D to A only one outbound and C to D only one outbound. Means the influence of C. Okay, the node D gets the full influence of C. Node D gets the full influence of C and there is only one outbound from D to A, no? So A will get the full influence from D, full influence from D. Okay, so now the node A gets the influence of node D fully. Please understand here, A gets full influence of D, half influence of B, half influence of C. Isn't it? Isn't it? So we get node A gets the full influence of D and half influence of B. Half influence of B. One minute. So D is fully influenced for A and there is an aroma coming out from B to A. So that makes the sense of, see here, D to A, okay, B to A. But here we get full. Here D to A will get full influence. B to A will get half influence. Half